Igneous rocks are formed through the cooling and solidification of magma or lava. The magma can be derived from partial melts of existing rocks in either a planet's mantle or crust. Typically, the melting is caused by one or more of three processes: an increase in temperature, a decrease in pressure, and a change in composition. And the solidification into rock occurs either below the surface as intrusive rocks, usually coarse-grained due to the relatively slow rate of cooling, forming rocks like granites, diorites, and gabbros, or on the surface to form fine-grained extrusive rocks like rhyolites, andesites, and basalts, which cool rapidly, giving no chance for mineral crystals to grow. In some instances, igneous rocks may form in between, which are then called hypobasals. Igneous rocks occur in a wide range of geological settings, such as shields, platforms, orogens, basins, large igneous provinces, extended crust, and oceanic crust. Igneous rocks form about 15% of the Earth's current land surface, and most of the oceanic crust is made of igneous rocks. A common classification for igneous rocks is based on their silica content, in which silica-rich igneous rocks, like the granite family, are classified as acidic. Those with an intermediate amount of silica represent the intermediate category, such as the diorite family, and those which are poor in silica are the basic and ultra-basic igneous rocks like the gabbros, peridotites, and donites. The scientific significance of igneous rocks can be summarized as their mineral and global chemistry give information about the composition of the lower crust or upper mantle from which their parent magma was extracted, and the temperature and pressure conditions that allowed this extraction. Their absolute ages can be obtained from various forms of radiometric dating and can be compared to adjacent geological strata, thus permitting calibration of the geologic timescale. Their features are usually characteristics of a specific tectonic environment, allowing tectonic reconstructions. As far as the economic significance of igneous rocks is concerned, orthomagmatic ore deposits are formed during their formation. These types of deposits form as a result of the accumulation of minerals during the solidification of magmas, and they are sources of chromium, vanadium, copper, iron, nickel, and platinum group elements. A good example of orthomagmatic deposits is kimberlite, which is an igneous rock that sometimes contains diamonds. These rocks form deep in the mantle in a high pressure and temperature environment that causes carbon atoms to strongly bond together, resulting in diamonds. Another example of orthomagmatic deposits are those generated from the impact of a meteorite, in which case the metals that are formed are not from the meteorite but from the Earth's crust. These sorts of deposits are a source of 1/3 of global nickel resources, in addition to large concentrations of magmatic copper, platinum, palladium, and gold. In their late stages of crystallization, igneous intrusions provide hydrothermal solutions loaded with precious and base metals, in addition to other non-metallic elements, to be precipitated in their host rock, forming hydrothermal deposits like those of porphyries, sediment-hosted and volcanic-hosted massive sulfides. Moreover, the heat associated with these intrusions and the circulation of hydrothermal solutions within the host rock result in alteration and metamorphism processes, allowing other types of ore deposits to form. Especially interesting clans of igneous rocks are lampreyres and lamproids. On one hand, lampreyres are uncommon small-volume ultrapotassic igneous rocks, primarily occurring as dikes, lopolis, laculis, stocks, and small intrusions. They are alkaline, silica undersaturated mafic or ultramafic rocks with high magnesium, potassium, and sodium oxides, and high nickel and chromium contents. And on the other hand, lamproids are ultrapotassic, mantle-derived, volcanic or subvolcanic rocks with low calcium and aluminum oxides and high potassium and magnesium oxides, as well as an extreme enrichment in incompatible elements.